Assalamu alaikum everyone. So lecture number 11, and today we will be solving some of the review questions. So let's start. These are the topics we will be talking about. First we will be differentiating between LANs and WANs, and we will be taking a review question after the discussion of LANs and WANs. Then we need a path reliability whenever we transfer data from one point to another point. So path has to be followed, and we need reliability in order to ensure error-free data transmission over the network. Then we will be talking about the circuit switching example, and we talk about one of the example that is actually driven by this switching technology. And circuit switching support some sort of routing, so we will be talking about routing that is supported by circuit switching. And then we will talk about semi-permanent permanent connection type, and after that we will be discussing Isdn technology. And after discussion of Isdn, we will talk about Datagram and virtual circuit operational differentiation. We will differentiate them on the basis of operational functionality. And there are some of the limitations when we talk about the data transmission while using the circuit switching. So we will talk about limitations introduced by circuit switching whenever data has to be transmitted. And finally we will differentiate virtual channel and virtual path that is related to ATM, asynchronous transfer mode. So let's start. So here we have our first review question. So we have to differentiate between WANs and LANs, wide area network and local area network. So you can see we have WAN on the left hand side of the slide, and we have a LAN on the right hand side of your screen. So you can see and you can gauge the difference on the basis of these two networks. So let's talk about, so whenever we talk about WANs and LANs, so actually in some scenarios even LANs and WANs, they act as backbone, especially whenever we talk about the wireless networking, wireless and mobile computing. So there has to be an infrastructure in order to support the services, the applications, and the functionalities for that wireless and mobile computing and communication. So that backbone can be provided by LANs, high-speed LANs or high-speed WANs. And then we also have some different infrastructure whenever our scope varies. For example, I have to support wireless and mobile infrastructure, and I have to focus on mobility. So I want to support mobility in my wireless and mobile infrastructure. For example, regarding GSM services, or maybe it's CDMA or something like that. So in that case, the scope of WAN and LAN has to be changed, right? So we will be having different scenario in that case. And in another case, I want to support GPRS service, that is the data service over the wireless and mobile infrastructure. So in that case, scope once again varies, and I need the backbone so that I will be able to support that data service onto my wireless and mobile infrastructure. So it is very important to define the scope whenever we talk about the LANs and WANs, right? So here we have high-speed LANs and WANs, And you can see that whenever we connect a number of high-speed LANs via some core equipment, so we can actually declare it a high-speed WAN. So after talking about wireless LANs and WANs, where we can have high-speed wireless LANs and WANs act as backbone in a different scenario. For example, we want to support the mobility, so we have built a wireless infrastructure and mobile infrastructure on the top of that high-speed LAN and WAN. So the scenario is can be a different issue. So here we have an overview of the wireless LAN. So we want to avoid that backbone infrastructure, so we have a LAN that is already deployed, and we want to extend that LAN in order to support the mobility and cross-building access, and then we can also have the ad hoc networking. So the key issues that can come across whenever we want to have that sort of infrastructure, they are low data rates and some of the safety issues and licensing issues also. So in that way we can have the so here we have a single LAN extension. So we have extended our existing LAN infrastructure, and we have built a cell that have both the wireless and wired access, and it supports mobility, ad hoc networking, and we can have access across the buildings. And if we join those different cells together, so we can have multi-cell LAN extension, right? So we have, you can see that in one cell we have frequency 1, and then in another cell another frequency is operating, and in the third cell third frequency is there. But all the wireless infrastructure is actually supported by this wired infrastructure that is acting as a backbone over here. So same issue or same feature, you can say, cross building interconnect. So we can have the facility or feature of cross building access. So this is about mobility. So somebody have its laptop or cellular phone which support data services or voice services. So he's accessing some service, for example voice over IP or maybe some other service. So he or she can move around and can access the services over the so this is the same. So here we have the scenario of the ad hoc networking. So whenever we need to build that sort of ad hoc network, so we can do that over the existing wired and wireless infrastructure. So here are some of the requirements of wireless LAN infrastructure. So we have already the technologies. That is also very, very important, that these are the technologies, spectrum LANs and OFDM LANs and infrared LANs. So here we have the answer to our review question, because we have discussed about LANs, WANs, their requirements, their functionality as a backbone, and how the scenario can be changed and the scope can be different whenever we talk about the WANs and LANs. So here I have added an additional, or you can say that the WAN is sandwiched between WAN and LAN. So now we are in a position to answer the question. So WANs or wide area networks are used to connect large area. So you can say maybe if a company has a lot of different offices in the big city, so they can lay the WAN infrastructure in order to connect all their offices. So maybe we can talk about the communication between cities, right? So with local area networks, so LANs actually, each building can be considered as a LAN when we talk about a company and they have different offices in different cities, or maybe the city is so large then they can have different buildings within that city. So each building can be considered as a LAN, right? So a network asset supporting a LAN belong to the organization. So obviously the company will own the LAN and they will interconnect. Maybe this can be one of the use cases that they will be hiring the services of a third party in order to connect their different offices. Right? So here we have an additional information, wide area wireless computing. So you can see that we have the internet, we have the mobile infrastructure, and we have the fixed infrastructure. So base station for cellular communication, and here we have the switching center, right? So here we have wireless computing, but in a different scenario, right? So our next review question. So why it is useful to have more than one possible path through a network for each pair of stations, right? So here we have one pair of station, host 1 and host 2, and they want to communicate with each other. So you can see that we have a lot of different intermediary nodes that come across whenever we have to transmit data from host A to host 1 to host 2. So one of the problem that can occur if, for example, we don't have any one path at node A, right? So that can be from node A to node B, and we ignore, or we don't have the path from node A to node D. So in that case, in case of this failure at node B, so we will be stuck, right? So we cannot transmit data. So we don't have any sort of communication between two stations, that is host 1 and host 2. So that is one of the requirement. In order to have reliability, we must have more than one path, or you can say redundancy. In order to support redundancy, we must have more than one possible paths between two stations, right? So here you can see that we have three different locations: Lahore, Karachi, and Islamabad. So here I'm talking about the delivery of packets. So if at this point we have only one path, that is this one, so if in case of link disconnection or some other problem, we will be stuck and we cannot transmit the packet. So if we have the alternate path, so in case of link disconnection or some other problem, we can transmit the data from here via this. So the destination is Karachi and the source is Lahore. So this is one path and this is another path, and here we have the third path, right? So we have reliability support and redundancy support over here because we are having more than one path. So the advantage is that in order to have reliability or support reliability whenever one of the path fails, right? So review question: what is the principal application that has driven the design of circuit switching network? So we have to give the main example, right, where the switching circuit network is used. So here we have very conventional PSTN network. So we have, this is the subscriber line, right, and this is the station or switch that is inside the central exchange, and then those central exchanges, they are connected to other central exchanges, they are having different switches, and then we have the callee, right? So here caller, and you can say that this is the callee if we want to call from A to B. And so let's talk about the switching techniques, because this is circuit switching, all about circuit switching, right? So data transmitted through a network of intermediate switching nodes which are not connected, concerned with the content. So these are the intermediary switches, and they are not interested in the content, right? So we have a lot of discussion about circuit switching. So here are some of the characteristics of switched network characteristics, right? So some nodes connect only to other nodes. For switching of data, other nodes have one or more stations attached as well. Links are generally dedicated, right? So network is only fully connected. So as we know, we talked about two different types of switching technologies, circuit switching and packet switching. So these are different phases. Whenever we talk about this circuit switching, we have to go through these steps. First, circuit has to be established between one leg and the other leg of the call. Then after the call setup, the data has to be transferred, right? And after both the parties, they have finished their communication, we will disconnect the circuit and the resources are free so that the other subscriber can use those resources. So here, circuit establishment. So this is all about call setup. Okay, then data transfer, right? So point-to-point transfer from source to node, internal switching, and multiplex transfer from node to node, right? So multiplexing is also one of the key element of circuit switching, circuit disconnect. So we have a lot of different parameters that are associated when we talk about the circuit switching characteristics. Channel capacity, right? And once the circuit is established, the network is effectively transparent to the users, resulting in negligible delays, right? So as the dedicated link has to be established between one leg and the other leg, so we have very little delay, right? So these are the applications which we are looking for: public switched public telephone network, private branch exchanges, and private wide area networks, right? So these actually are used in order to connect PBXs, right? And then data switch. So these are the key elements of PSTNs, public switched telephone networks: subscribers, then subscriber line, that is from the subscriber premises to the central exchange premises, and this is normally called the local loop. And then exchanges. In exchanges we have a lot of different equipment, switches, trunks, right? End office, and then trunks. Those trunks, they are used in order to connect exchanges, and it can carry multiple voice circuits, and the technique used is FDM, frequency division multiplexing, and TDM, time division multiplexing. So whenever we talk about the circuit establishment before the actual data starts flowing in case of circuit switching, so we need to have a control protocol, and that control protocol is actually is based on the control signaling. And one of the example is SSS7, that is the protocol which is used in order to set up the call between one subscriber and the other subscriber. So here are some of the signaling functions. transmission of number of dialed, of the number dialed, right? So whenever we want to have a call, we dial a number in, right? In both cases, when we talk about the cellular communication or PSTN communication, right? So between switches that a call cannot be completed, right? So this information is also carried out on the basis of signaling, and then ringing and billing, right? These all are related to signaling. Supervisory signals, then addressing, call information, and network management, right? So here we have more details. Then we have also channel signaling, and here we have the source switch. Most of the functions of this switch that are actually hardware based, they are actually implemented by using the coding, software coding, right? So here we have the traditional circuit switching infrastructure, and here we have the source switch infrastructure. So here we have the answer that the principal application that is driven by the circuit switching network is conventional telephone infrastructure, or conventional PSTN lines, or conventional telephony network. So let's talk about routing. So we have to distinguish between static and alternate routing in a circuit switching network. So first we need to understand about routing. So it's about selection of path from one point to another point within the switching network. So there are some requirements before the establishment of that path: efficiency, and then resilience, right? So ability to handle expected load of traffic, and then we also the infrastructure should also be able to handle surge of traffic that exceed the load. So here we have routing in circuit switch networks. So of course, whenever we talk about the connection between different nodes, so we need paths, right? So the criteria of building that path is efficiency and resilience. And in public switched telephony, we have a tree structure. Static routing uses the same approach all the time, right? And then we have the dynamic routing, right? So here we have different routes depending upon the traffic conditions. So conventionally in circuit switch networks, routing is static, hierarchical tree structure with additional high usage trunks. So here we have the alternate routing, is a form of routing in circuit switching network. So it includes all possible routes between end offices, right? So originating switch selects appropriate route, and we have listing of routes in order. So first preference, second, third, and so on and so forth, and different set of routes may be used differently. So again, alternate. So here we have the graphical interpretation of alternate routing. So you can see that we have route A, right? And then we have route B, right? XJY, and then we have route C, XKY, right? So XKY, right? So here we have some of the preferences, right? Time period, first route, second route, third route, these are the preferences, right? Final route, and this is the time of the day, you can see, say, because at different point in time the traffic or the circuit switch network may vary. because during the business hours there may be high traffic. And so here we have the answer after discussing a lot about the routing. So static routing involves the use of predefined route as obvious, and we have talked about this static routing between any two endpoints, right? So even in that case we have backup routes to handle overflow, right? In alternate routing we have multiple routes and their preferences, and depending upon the condition we have different preferences. So here we have, you can say this is very close to a routing table, but we also have preferences, right? Right. So semi-permanent connection. So in order to answer that question we have to go back to the ATM, that is asynchronous transfer mode. So here we have the protocol architecture of ATM. So you can see physical layer, ATM layer. So this is adaptation layer, and then we have the control. This is the management plane, control plane, and user plane, right? So here we have some of the details about those different planes. Provides user information, control plane, right? So it's obvious it is relevant to the control signaling, so call and connection control, and then management plane. So it is actually managing the whole system functionality, and then because we have different layers, so we should also have the layer management. So here ATM logical connections, so virtual channel connection, right? So it's very close to virtual circuit in X.25. We have basic unit of switching, and it is full duplex, right? So it means that we can have communication in both ways. Actually, when we talk about the ATM, we have a fixed cell size that is of 53 bytes or 53 octets, 48 bytes for the payload, and 5 bytes or 5 octets for the control information, right? So virtual path connection, that is also one of the key element, right, regarding the ATM. So here we have shown the virtual channel, right? So you can see that physically we have one transmission path, but virtually we have divided that channel into virtual channels, right? So these are the virtual channels, right? So, and then we have defined virtual paths. So one of the key advantage of the virtual paths is that we have a simplified network infrastructure, and we can also have increased network performance and reliability. This is a very key element, that whenever we talk about the reliable communication, so we need to do something additional, and reduce processing, short connection setup time, and services are enhanced. So virtual path and virtual connection characteristics. So the one of the main advantage of virtual path and virtual connection is the support of quality of service. So whenever we need to transmit or converge services, as in case of ATM, we want to support data services, voice services, and video services, right? So we need to support quality of service, because both the voice, video, and triple play services, they are very immune, they can be affected badly by the absence of quality of service. So we need to have the quality of service in order to ensure the effective and efficient delivery of those converged services. So switched and semi-permanent channel connection. So this is one of the characteristic of the virtual path and virtual connection, right? So switched and semi-permanent channel connection. It's not permanent, it's semi-permanent, right? So here we have the answer to our review question. So actually semi-permanent connection is a type of connection where we have established connection to another user setup by prior arrangement and not requiring a call establishment protocol, right? So we don't need a call establishment protocol, right? So it's very close to a lease line. Here we will be talking about ISDN data rates. So what data rates are offered for ISDN primary access? So ISDN is known as Integrated Services Digital Network, and we should not confuse this with SDN, that is actually very hot nowadays, that is software defined networking. So the main feature of ISDN, or the main requirement that is fulfilled by the ISDN technology, that we can transmit data, audio, image and video on a single link, right? So actually it is a switched digital telecommunication line that can be delivered or that can be terminated to the premises of a user over a normal copper pair, right? So we can use the existing PSTN line infrastructure where they are using the copper pair in order to have the circuit switching network, right? So whenever we want to have a telephone line, so that is actually being provided by PTCL, and they normally lay a copper pair from central exchange, from exchange which is nearby to our home premises, right? So we can use the same copper pair, but we need to have some specialized equipment in order to support ISDN line. So if we have that equipment, and on the exchange side we also must have some special equipment, so in that way we can have ISDN line terminated at our premises, right? So provide end-to-end digital communication. So here we have the basic characteristic, that here you can see that we have B channels, that is actually called bearer channels, and then we have D channels, and sometimes they are referred to as delta channel or control channels. So B channels, they carry data, right? And for D channels, they are actually used for signaling or for controlling the communication between endpoints. So we have two different types of ISDN depending upon the requirement of the user and the scenario where we are going to use, right? So first is the basic rate interface, or BRI. So that normally is used by a normal user and the small office, home office environments where we don't have a very hi-fi sort of data speed requirements. And then we can have another type of ISDN, that is PRI, primary rate interface. So this is deployed whenever we need high speed communication. So in BRI we have two B channels, bearer channels for data, one D channel for control information, and B channel that I have already mentioned. So B channel, it is actually 60K BPS bits per second, can be inverse multiplexed, right? So D channel actually it is 60K BPS, but we can have from 60 to 64 kbps depending upon the requirement, right? So here we have the properties of B channels in PRI, D channel in PRI. So here comes the review question answer. So we can calculate the data rate. So here I have mentioned PRI T1 line, right? So and I have calculated, because it contains 23 bearer channels, 64K of each, and one D channel 64K, right? So the total comes out to be 1.536 megabits per second, K and K mega, and then we can multiply, right? So another question, we have to differentiate Datagram and virtual circuit on the basis of operational setup, right? So packet switching, as we all know that in packet switching we have two different switching techniques. One is Datagram and the other one is virtual circuit, right? So actually packet switching was invented in order to support data communication for longer distances, right? We divide the actual data into segments, and then we transmit those segments that are called packets, and independently, and those packets, they can follow different routes. Data are transmitted in packets, so there is some upper bound regarding the segmentation or the packet size, right? And then obviously we need to add control information so that we will be able to reassemble those packets into the actual data, right? So that is the retrieval of data. Then whenever we talk about the transmission of those packets over a network, and where those packets, they will be following different paths independently, so we need to have some sort of addressing scheme, right? Source address and then destination address. And the basic technique that is followed whenever we talk about the transmission or communication on the basis of packet switching is store and forward. The packets are stored on a node and then forward, store and forward. So these are some of the advantages of the underlying packet switching technology: line efficiency, and we can get the maximum throughput, and then packets are accepted even when network is busy. So we can build different queues, buffers, then we can also define certain priorities. So techniques that are being used in packet switching, virtual circuits, and Datagram. So Datagram packet switching, each packet is treated independently, right? So each packet is independent unit of communication, a unit of data, and it is being routed or transmitted irrespective of its native source, right? Any practical route, so as a result they can follow any route. So as they are following different routes, so this is very natural that they will be arrive at the destination in different order, right? So there can be a problem whenever one of the packet is go missing, so we can have some algorithms or some sort of methodologies in order to send a request to the sender that this packet is missing, so please retransmit it. So here we have the packet switching Datagram approach, right? So you can see that the packets are being treated independently, then they are following different routes. So the transmission has to be initiated here, and then here we have the destination, source and destination. So you can see, so here we have the virtual circuit packet switching. So its pre-planned route is established before the start of the packet transmission, and of course whenever we have to establish a route before the actual packet communications started, so we need to have a dialogue between the sender and the receiver. So this is called the call setup. So all the packets in virtual circuit packet switching, they follow the same route, and as a result they arrive at the destination in sequence. So the disadvantage of this technique is that we come across some sort of delay, but at the beginning, whenever the actual data has not started flowing, we need a setup time in order to have a dialogue between sender and the receiver. So another advantage of this, that in case of Datagram, each packet is treated independently and at different nodes, intermediary nodes. So the routing decision has to be taken whenever a packet is staying at a node. So here the packet has to be treated independently and decision has to be taken. So there can be a delay for routing decision making. So susceptible to data loss in the face of link, right? So okay, so here we have the packet switching virtual circuit approach. So you can see that this dotted line showing the establishment of the virtual path before the actual communication starts. So before the actual data starts flowing, or actual packets they has to be transmitted, a virtual link has to be established between source and destination. So those two endpoints, they will talk, and with each other. Also maybe if we have different choices, so there can be possibility that the intermediate nodes, they also participate in that dialogue, that they, if it has to be decided that what is the capability of the packet size that can be accommodated between source and destination. So this is also very important regarding the intermediate nodes, right? So here we have the comparison, virtual circuits and Datagram. Network can provide sequencing and error control, right? So because we have a one or single path between source and destination, so the data arrives in sequence and we have error control, right? So packets are forwarded more quickly because at intermediate nodes we don't have to take the routing decision because it's already predefined. In that case, you can see that it's predefined that from this node the packets has to be transmitted here. So no decision is required. So as a result, we have very quick packet communication, so less reliable. So if imagine one of the intermediate node that is lying in between the virtual path, it get failed. So then the whole communication will be stopped, and we have to do everything from scratch. Then on other side, Datagram, no call setup phase, right? So as opposed to virtual circuit where we have to establish virtual circuit before the actual communication starts. So here we don't need the call setup phase, right? So it's more flexible because of routing via different paths. Right. So here we have external virtual circuit and datagram operation, and internal virtual circuit and datagram operation. So you can go through by yourself. So here is the answer, right? In datagram, each packet is treated independently, right? So as a result, the packets are following different paths, right? So as a result, they can reach at the destination out of order, and we should have a mechanism in order to reassemble those packets in order to get or retrieve the data. On the other side, in virtual circuit approach, path has to be established before the actual communication is started, right? So we need to have a dialogue between source and destination. So as a result, there is a delay in the form of call setup, right? So all packets, they are following the same path, so no routing decision at the intermediate nodes, right? So then what are the limitations of circuit switching whenever we talk about the data transmission, right? So here we have circuit switching. So source creates circuit to destination, right? So whenever we talk about, so somebody has to make a phone call, right? So first he will pick up his phone, and if the tone is there, he will dial some numbers. So whenever he is dialing the number, there has to be established a circuit, right, between the source and the destination. So that is called the call setup, right? So node along the path store connection info. Nodes may reserve resources for the connection, right? So then this is the establishment. So the path is established. So from here, and then these are the intermediary nodes or switches. So each switch is reserving path for the upcoming communication. Then after the connection is established, then you can imagine, or you can realize that whenever after dialing the number, we have to wait for some time, and this is the time where the actually connection is being established and resources are being reserved. And after that, you can see that the destination phone rings, and when the callee pick up the phone and we start talking, at that time the actual data starts flowing. So here the timing in circuit switching, right? Circuit establishment, the actual data transmission, and then the circuit tear down, and we have freed the resources so that it can be used for some other communication, right? So here we have host 1. So here we have the circuit switching in the context of computer communication, right? So here is the answer. Circuit switch network for data, since much of the time a typical terminal to host data communication line will be idle, right? So we cannot have the data communication because we need to establish a connection before starting the actual data. So most of the time, if nothing has to be transmitted, the connection will stay there, and it will sit idle, and we will be wasting a lot of resources. So this is one of the reasons that we should not use circuit switching for data transmission, right? And the second reason is the connections provide for transactions at a constant data rate, which limits the utility of the network in interconnecting a variety of host computers and terminals, right? So this is the second limitation. And there are some other reasons, right? Because actually the circuit switching is designed for voice communication, but data communication it has. Moreover, there are some other limitations, like circuit switching was actually invented for voice communication. So it is not useful to use circuit switching for data communication because resources are dedicated and circuit is established, and if we have, because data is actually transmitted between source and destination in chunks, right? So there can be idle time when there is no data communication, right? And we know that normally the data rate is fixed between the endpoints, right? So that can also one of the reason that we should not go for circuit switching in order to have data transmission. So here we have the last review question. So we have to differentiate between virtual channel and virtual path. So as we have already discussed about virtual channels and virtual path, so you can see the division of a single physical transmission path into virtual paths and virtual channels, right? So as a virtual channel, it's a logical division, right? And the example is a virtual circuit in X.25, or you can also have a logical channel in frame relay, right? So when we talk about the ATM, virtual channels have the same endpoints, right? The endpoints are the same, and they can be grouped into virtual paths. So all the circuits in virtual paths are switched together, and as a result, the efficiency is increased, and we have very simplified architecture, and we can also have converged services, right, over the same network infrastructure, right? So that's all. So here is the summary. We talked about the LAN and WAN difference, and we also discussed the scope change whenever we talk about the high-speed LANs, WANs, right? And we also talk about different infrastructures where we have LAN and WAN infrastructure as a backbone, and over that backbone, or using that backbone, we can achieve different scope objectives. Then reliability, why it's better to have more than one path when we talk about the communication, right? So in order to support reliability and redundancy, we should have more than one path. If one of the path fails, then we should have a backup path so that we can transmit our data by using that path. Then we have discussed about the example or working example of a circuit switching network, that is the PSTN line, and we talked about different steps that has to be followed in order to have a communication when we talk about the circuit switching network. And then we also discussed about ATM, and in that discussion we included semi-permanent connection, and after that we talked about the data rates that are being offered by Isdn, PRI, primary rate interface, and BRI, and the number of channels, both two different type of Isdns they are supporting, and there is actually a difference between standards when we talk about the Isdn in US and Isdn Europe, right? So, and we also talked about Datagram, that is a packet switching technique, and the virtual channel connection, that is also a packet oriented technique. And then we talked about the drawbacks if we want to transmit data by using circuit switching networks, right? And in the last we talked about ATM, and we discussed virtual path and a virtual circuit. And that's all for today's talk. अपना ख्याल रखिएगा. मेरी तरफ से अल्लाह हाफिज़. अस्सलाम वालेकुम.